This is the research overview for August 7th, 2026. It is AI-generated, based on a partial daily collection of 30 paper analyses, and requires human review before publication or decision-making. Today's strongest theme is not simply bigger models. It is better internal structure, denser learning signals for agents, explicit representations of future states, more auditable evaluation, and task-specific supervision for retrieval and language adaptation.
Start with agentic reinforcement learning. Agent OPSD turns differences between an ordinary policy and a privileged self-teacher into credit for individual action turns. On the reported household benchmark, the full method reached 89.1% success. Using token accumulation instead gave 85.9%, and replacing recursive belief revision with raw local evidence gave 82.8%. Those ablations support the value of turn-level aggregation within that benchmark, although missing main table cells and absent run-level uncertainty limit broader claims.
NVACE attacks sparse feedback differently. One shared policy learns both to take tool actions and to rehearse the environment responses those actions might produce. At 8 billion parameters, rehearsal raised the reported task average from 31.2 to 36.7% on one tool use benchmark. Two private rehearsals before actual execution raised an overall measure from 36.7 to 40.9%. But the paper does not directly measure whether imagined responses match the real environment, and additional rehearsal was not consistently better.
That creates a useful same-day comparison, but only an editorial one. Recursive credit refinement versus learned world rehearsal. Neither paper proves that its internal signal identifies the actions that causally matter. A decisive experiment would replace selected actions, run counterfactual continuations, and compare predicted importance with exact environment state changes. It would also vary the quality of privileged skills and measure rehearsal fidelity, rather than relying exclusively on final success.
Evaluation infrastructure supplied an important reality check. A standardized computer use study tested judges on 1,019 human-labeled trajectories. The best frontier result approached 90% accuracy on the full set, yet the best raw accuracy on a deliberately difficult subset was only 69.7%. Across judges, false acceptances outnumbered false rejections by roughly 3 to 1. That is measured evidence of leniency under this protocol, not proof of the same error rate in every deployment.
Data agents showed a related need for auditable outputs. DataSpace asks agents to discover and join evidence across databases, documents, files, languages, and video, then submit complete tables for deterministic checking. The best fixed harness result solved 272 of 410 tasks, or 66.34%. Tasks requiring joins trailed tasks without joins by between 9.7 and 19.8 points across 6 backbones. Those gaps are descriptive, not causal, but they expose a concrete weakness in cross-artifact integration.
Visual reasoning papers converged on predicting hidden or future states. Chronovision reconstructs a final visual state in latent space while ordering shuffled frames. Its exact match score rose from 66.0% without the reconstruction head to 69.0% with it, 70.2% with region supervision, and 73.2% after reinforcement learning. The staged ablation supports several components on the paper's fixed 6-frame benchmark. Still, dense generated cues, bounding boxes, and synthetic data constrain the generalization claim.
Global spatial understanding remains much harder. On GST Bench, a leading proprietary model scored 42.68, compared with a reported human estimate of 79.08. Targeted training lifted an 8 billion parameter model from 25.89 to 53.52, a large measured improvement, but still left a 25.56-point human gap. Because training and evaluation share a synthetic generation pipeline, the next test should freeze the trained model and evaluate independently collected real video with random, budget-matched, and Oracle evidence routing controls.
Robotics echoed the future prediction theme. World to Wrist predicts task-conditioned wrist camera latents and reported 98.5% average success across 2,000 simulated trials, plus 70% mean success across 3 physical tasks. DIPES VLA combines shared predictive dynamics with embodiment-specific action experts, reporting strong results across 3 simulated suites. Its physical result followed demonstration-based fine-tuning, so it does not establish zero-shot transfer to a new robot body.
A strong open question is whether predictive representations actually transfer across embodiments. A matched study could hold the encoder fixed and compare wrist local predictions, monolithic future states, and factorized layout, agent, and interaction targets on a genuinely novel robot. The study should separate zero-shot use, training only a new action head, and full fine-tuning. Without those controls, high scores across existing suites cannot tell us whether models learned portable dynamics or merely adaptable task features.
Retrieval research emphasized learning from specific failures. UNAMI R1 inspects initially retrieved hard negatives, then chooses between re-ranking candidates and reformulating the query. Its reported overall score was 69.9 versus 65.6 for query-only reasoning and 63.5 for initial retrieval. Adaptive routing narrowly beat always re-ranking or always retrieving again. Yet teacher and judge labels lacked an independent human audit, so the measured gains validate the pipeline, not every generated explanation of failure.
Greek retrieval illustrates why transfer must be tested outside the adaptation set. Specialist retrieval improved sharply from 0.3617 to 0.8352 on its reported ranking metric. On unseen Greek Wikipedia, however, traditional term matching scored 0.6442, ahead of the adapted dense model at 0.5637. Combining methods reached 0.6715. That measured reversal across settings argues for independently authored queries, end-to-end retrieved context testing, and separate scoring of answer correctness, grounding, citation accuracy, and abstention.
Underserved language results also separate task accuracy from language behavior. English-only math distillation improved Korean and Japanese accuracy, but response language rates fell sharply relative to multilingual training, from 90.5 to 48.3% in Korean, and from 90.9 to 29.6% in Japanese. Meanwhile, targeted Yiddish training improved aggregate evaluation and specific morphological subsets. The editorial inference is that multilingual capability needs at least 2 scorecards: solving the task and responding in the requested language.
The concise takeaway is that internal structure helped across agents, vision, robotics, and retrieval, but the strongest numbers remain tied to distinct datasets and incompatible metrics. They should not be ranked against one another. Key next steps are causal validation of agent signals, real-world tests of spatial reasoning, genuinely new robot embodiments, human-audited multilingual retrieval, and matched speed-quality studies. For the complete paper-by-paper evidence, caveats, and links, consult the linked daily summary.